6.3, we're going to look at a different type of factoring now. Remember we talked about the GCF, the greatest common factor, and we always want to be looking for that GCF, so I'm going to remind you constantly, no matter what problem I give you, look for a GCF first. Is there something in common that all the terms have? But for the most part in this section, we're going to be worried about the other type of factoring, which we'll see in a second. Right? But it's going to work for any polynomial that takes this form. Right? An x squared term, an x, and a constant term at the end. Right? It won't work for all of them, but whenever our polynomials look like this, we'll attempt to take this route to factor. So before we look at factoring it, let's see where it comes from and kind of recap. Right, this problem, x plus 4 times x plus 5. Right, this we already know how to do from chapter 5. We know how to multiply these two binomials together. Right, we distribute the x, we distribute the 4. Right, that's the process called FOILing. So we'll do this really quickly. Right, and just keep a close watch over where all of my terms end up coming from. So this first term I write comes from the first two pieces from the FOIL, x times x. Right, then we have the outside, x and 5, 5x. We have the inside, 4x. Right, so the outside and the inside give me two x terms. Okay, and then my last, 4 times 5, give me my constant term of 20. We combine our two middle terms. Remember, those are the outside and inside. And we end up with x squared plus 9x plus 20. So now we have a polynomial, a trinomial to be exact, that takes the same shape as this section's title. Okay, we have an x squared term, a bx, and a c. And clearly, I mean, we just saw where this comes from. It comes from two binomials being multiplied together. So that's going to be the name of the game. Can I look at x squared plus 9x plus 20 in reverse course and get back to those two products that are binomials, right, that we need to multiply together to end up here? So the process is less complicated than it may seem. You always want to start off by looking at, is there a common factor between these three terms? So I'm going to reiterate that a lot. Right, there's no x in common because there's no x in this last term. Right? And numerically, 29 and 1 don't have anything significant in common. Right? So if you can claim that there's no GCF, right, the only other way for us to factor a polynomial in this class is to break it apart into these two binomial pieces. So I'm going to call this unfoiling just for ease. Right? If foiling is multiplying two binomials together, unfoiling is going to be taking it apart and breaking it into two binomial pieces. So we already know what the answer is, but let's pretend we don't and see how we get there. Right, we know that these first two terms, when we multiply them out, they should give us x squared. So by default, it has to be x and x. Right. Next, we kind of skip over the 9x, this middle term, because it's more complicated to get to, and we look at the 20. Because we know that whatever two numbers we place here and here, right, when we FOIL this out and we multiply them together, they're going to get us this constant term. So it's pretty straightforward. Whatever two numbers I place here, multiply to get 20. So if I didn't know the answer was already 4 times 5, I might cycle through my possibilities for options here. There's not going to be many. Right? I have 1 times 20, 2 times 10, and 4 times 5. So if it helps to write them out, by all means do that. But you can also probably think through them in your head and figure out which one is going to work. Right? Well, not all of them are going to work here, even though all of them do multiply to get 20. We need to figure out how to get 9 in the middle now. And notice where that 9 came from. Right? It wasn't random. Right? It came from the 5 and the 4 being added together. Right? So we're going to go through these options and try to figure out, well, all of them multiply to 20, but which of them can add up to 9 in the middle? So once you identify the pair that'll do that, and there's usually only going to be one. I'd say 99% of the time there's one pair that'll add up to this middle term, and we'll probably see an example where there's more than one pair, and you have to be careful, but most of the time one pair will be the only pair that works, so we know it has to be a 4 and a 5. It doesn't matter in this case where you put the 4 or the 5, because 4 times 5 is certainly 20, and we need to figure out what two signs I would put in here to make 4 and 5 add up to positive 9. So in order for that to happen, we would need positive 4 and positive 5, and we've factored this. Right? X times x is x squared, 4 times 5 is 20, and 4 plus 5 is 9. Right? That's the idea. There's not really too much more difficult of a difficult sense about it, so we'll just practice a few more, and I'll try to point out some tips and tricks along the way. X squared plus 8x plus 12 and I'm going to put up 4 problems on the board. Alright, just to illustrate a point here, I think that's going to be a 4. Right, they're all very similar. They all have an x squared to start off. They all end in a 12, whether it be positive or negative. And their middle terms differ slightly. So the same thought process is going to run through every scenario, right? But I remind you, you want to be looking for a GCF, right, in every problem, right? But in this case, I've made them so none of them have a GCF, and you can double check that, but there's no x in any of the last terms, so there's no x in common. Right? And the coefficient of all the beginning terms is 1, so you're not going to have any significant numerical common factor. Right? So there's no GCF. Right? Again, this is not always the case. We're going to look at some instances that have GCFs in a second, but for now, let's just focus on this unfoiling technique. Right? If there's no GCF, every one of these problems has to start off, right, with 2 binomial pieces. So I am going to start there. Okay. Not only that, every piece has to start with the same 2 first terms. I need to get x squared, so I need x and x. Fair enough. Also, every single one of these problems ends with a 12. So that would mean the 2 numbers that I place at the end of each one of these binomial pieces has to multiply to get 12. So my options are 4 times 3, 6 times 2, and 12 times 1. Alright, so again, what we just saw is we want to look through all these pairs and see which pair can help us add up to the middle term of 8. When I say add, I mean combine. Right? I tend to say add because when I think add, I don't distinguish between positives and negatives. I can add positives and negatives together as well. I'm just combining. These numbers can be positive, they can be negative. We're just going to group together 2 numbers. Right? But in either case, if I wanted to get 8, right, hopefully your response would be 6 and 2, because those 2 positives certainly add up to 8. So it doesn't matter where you put the 6 and the 2 in this case. We just need to make sure that the 2 signs make sure they add up to positive 8. So we need 2 positives here. And just as a side note, as a little tip, right, if your trinomial that you're starting with is all plus, 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 right, your answer has to be all positive signs too. You're never going to have a negative in it, so it's safe to assume plus, plus, your answer is plus, plus. Right, how can we change this scenario? Our three pairs of factors that we have to choose from are going to be the same for all the situations, but now I want negative 8 instead of positive 8. Well, hopefully that doesn't change the pair that you want to choose from. Right? 6 and 2 still get me to 8, so I'm still going to use 6 and 2. But how's that going to change my signs? If I want to make a negative 8 in the middle instead of a positive 8. Well, if I want these two numbers to add up to negative 8, hopefully, and we can come to the conclusion that if both of these are negative, right, that's the only way for these to add up to negative 8. Negative 6 plus negative 2 is negative 8. And negative times negative will give me positive 12. So there's two reasons why both of these have to be negative, and it, again, is another tip and trick that you can use along the way. If your signs in your initial polynomial are minus, plus, right, your answer is always going to have two negatives in it, right, for the main reason that they have to multiply to get a positive constant term. The only way to multiply to get a positive constant term would be positive, positive. Well, you know that's not going to be the case, because how's this negative going to show up? The only alternative way for you to get positive 12 at the end would be negative times negative. So it's another definitive, nice trick to use. If you have this specific scenario with a positive at the end, negative in the middle, it has to be negative, negative. Right, but I don't like to rely on tricks. I'd rather just trust myself. I know that negative 6 plus negative 2 is negative 8. Right, go with your normal number operations that you're confident in, instead of worrying about a trick to remember. Right, and these last two, now I want middle terms of 4, positive 4x or negative 4x. Right, but the same pair we're going to use the pair 6 and 2. And we want to put the correct signs to make these two numbers group together to get positive 4. Okay, so if I wanted positive 4, I would need more positives than negatives. Right, 6 minus 2 is positive 4, so those are my positive 4x, and positive times negative will give me negative 12. So if this last term is negative, you know definitively that one of my signs has to be positive and one has to be negative, because I need to multiply to get a negative 12. Right, so you can use that to your advantage, where you know one's positive and one's negative. You just have to put it correctly to make sure you end up with a positive 4x. Right, with that in mind, right, check out this one. Right, this one has to be 6 and 2. Right, but how's that going to affect my signs if I want negative 4 now? Right, well, in this case, now I need more negatives than positives, so this would be a negative 6 and a positive 2, and that'll work out as well. So, all right, there's 4 quick examples that kind of illustrate the power that you have to factoring these. And just to emphasize that final point is, right, when you pick one of these pairs, 4 and 3, 6 and 2, 12 and 1, right, there are 4 different outcomes that each of those pairs can get you to. If I add 6 and 2, both positive together, I can get positive 8. If I make them both negative, I can get negative 8. And if I find the difference between 6 and 2, I can get a positive 4, or I can get a negative 4. So there's 4 possible outcomes for you to get with any one of the pairs. So just to point out, if I chose 12 and 1 as one of my pairs to use, I could get a middle term, and if I added them up, I could get 13 as a middle term. If I made them both negative, I could get negative 13 as a term. If I subtracted these two, 12 minus 1 is 11, so that means I could get 11 as a middle term, or I could also get negative 11 as a middle term. And so again, every pair of numbers has 4 possible outcomes for you to get to, and you can use that to help build this middle term.